I am Assistant Professor Milan Patel, ME Electrical Power System from the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today, I will deliver a video lecture on the Introduction to the Control System, chapter number 1 from the subject Control System Theory, having subject code of 3130905. Today, I will discuss the topic classification of control system. Now flow of contents. So first topic is linear and non-linear control system. Second one is time varying and time invariant control system. Third one is transfer function. Fourth one is Laplace transform. And last topic is examples on the Laplace transform. Now classification of control system. There are main two types of the control system. First one is linear control system and second one is non-linear control system. So what is linear control system? When an input of x1 produces an output of y1 and an input of x2 produces an output of y2, then any combination of alpha x1 plus beta x2 should produce an output of alpha y1 plus alpha y2, where y1 is a output from the x1 input and y2 is a output from the x2 input. Alpha and beta are the constant. In such case, system is linear. So therefore linear systems are those where the principles of superposition and proportionality are obeyed. So linear systems are those who will obey the uh, principles of the superposition and the proportionality. So this is a linear control system. Now non-linear control system. Non-linear systems do not obey law of superposition and proportionality. The stability of non-linear systems depend on the root's location as well as initial condition and the type of the input. So a non-linear system will depend on initial condition and type of input. And the last one is non-linear systems exhibit self-sustained oscillations of fixed frequency. So non-linear system will exhibit the self-sustained oscillations of the fixed frequency. Now difference between linear and non-linear system. So first one is obey the superposition theorem. Linear system will obey the superposition theorem, where the non-linear system do not obey the superposition theorem. Can be analyzed by standard test signals. Cannot be analyzed by the standard test signals. So non-linear system cannot be analyzed the standard test signals. Stability depends on the root locations in the linear system, where the stability depends on the root location as well as initial condition and the type of input for the non-linear control system. So linear system do not exhibit limit cycles, where the non-linear system will exhibit the limit cycles. Do not exhibit hysteresis or jump resonance, where nonlinear system exhibits the hysteresis and or jump resonance. Linear system can be analyzed by Laplace transform and Z transform, where the non-linear system cannot be analyzed by the Laplace transform or the Z transform. So analysis of the non-linear system is the toughest job. Now another classification of control systems. So it's divided in time varying control system and time invariant control system. So as its name suggests, a system whose parameters vary with the time are called time varying control system. So the system in which the parameters of it are dependent on the time is called time varying control system. When the parameters do not vary with the time are called time invariant control system. The mass of missile or rocket reduces as fuel is burnt, and hence the parameter mass of fuel is time varying and the control system is time varying type. So as the time increases, the mass of the fuel decreases. That's why the parameter of the fuel mass is decreasing. That's why it is a time varying control system. Now transfer function. What is transfer function? So transfer function is used to define the relation between the input and output of the system. So the definition of the transfer function is given by the ratio of Laplace transform of output to the Laplace transform of input under the assumption of zero initial conditions is defined as transfer function. So transfer function is nothing but the ratio of the Laplace transform of the output to the Laplace transform of the input under assumption of zero initial condition is called transfer function. Now transfer function, this is a simple block diagram for the control system. This is the system small g of t, because this is time domain system. That's why we have taken t for time. So this is g of t means process or system, r of t means input, c of t means output, g of t means system function. So this is in a time domain system. Now we will take Laplace transform for this whole system. So we can write r of t, so capital R of s domain stands for the Laplace transform. So r of s as a input for the Laplace transform system. Then capital C of s for the output, and system capital GS for this system. Now we can say that C of s is equal to nothing but Laplace of this. Laplace of Ct is given by capital C of s. Laplace of Rt is given by capital R of s. And Laplace of Gt is given by capital G of s. So from this system in S domain, we can define our transfer function g of s by Laplace transform of the output divided by Laplace transform of the input. So here Laplace transform output is c by c of s and Laplace transform input is r of s. So this is called c of s divided by r of s is our transfer function for the particular system. So now transfer function of a closed loop system. So this is a block diagram for the simple closed loop or feedback control system, in which this is input, this is summing point, this is a system, this is a output. So this is a feedback signal and this is a feedback system. So this summing point will create a error signal from this feedback signal and the input signal. ES is the error signal. So from this block diagram we can say that error signal is given by ES is given by RS minus BS. So ES is equal to RS minus BS. So we can write RS is equal to ES plus BS. Now gain of feedback network is given by HS is equal to output by input, because we can see that this is the input for this HS system and this is BS is the output signal. So BS by CS is transfer function for the HS. So we can write BS is equal to HS into CS. Now gain for control system closed loop system is given by GS output CS divided by input ES. We cannot take RS as an input because for this GS system, the input signal is our error signal. So we can write C of S is equal to G of S into E of S. So substitute the value of ES from equation 1 to 3. So put the value of equation 1 in this equation number 3. So ES value is RS minus BS is replaced by this value. So C of S is equal to G of S into RS minus BS. This is the value of ES. Now C of S is equal to G of S into R of S. Again G of S in minus into B of S. So G of S RS minus G of S BS is our equation number 4. So substitute the value of B of S from equation 2. Equation number 2, value of B of S, H of S into C of S in this equation. So our equation will become C of S is equal to G of S into R of S minus G of S into value of B of S is equal to H of S into C of S. So now take this negative term at the left hand side. So our equation will become G of S into R of S is equal to C of S plus G of S into H of S into C of S. So in this equation C of S is common, so we can take C of S common. So our equation will become C of S in bracket 1 plus G of S into H of S. So this is our G of S into R of S value. So now we can write our transfer function by T of F transfer function TF transfer function is equal to output divided by input C of S divided by R of S. So here C of S and R of S is there. So we can take simple R of S in divided by the C of S and this whole term in denominator for this G of S term. So our transfer function for this closed loop system will become G of S divided by 1 plus G of S into H of S. This plus sign will change negative for this feedback signal positive. When the feedback signal sign is negative, then this sign is positive, and for this positive sign of the feedback signal, this sign will negative. So this is a transfer function for the closed loop control system. Now Laplace transform. So the French Newton pair Simon Laplace is the founder for this Laplace transform. He developed mathematics in astronomy, physics and statistics. Began work in calculus which led to the Laplace transform. Focused later on the celestial mechanics and one of the first scientists to suggest the existence of the black holes. So the French Newton Pierre Simon Laplace is the founder of the Laplace transform. Now what is Laplace transform? To evaluate the performance of an automatic control system, commonly used mathematical tool is Laplace transform. So Laplace transform converts the differential equation into an algebraic equation in the form of S, where the Laplace transform exists for almost all signals of the practical interest. Laplace transform. So Laplace transform is used to convert this time domain signal in frequency domain signal or function. So in time domain function, we have f of t, d of dt form and differential equation. We can directly solve them in time domain function, but it is very hard to solve this differential equation in the time domain. That's why we have to convert this time domain signal into the Laplace transform form or in frequency domain function, and then solve this algebraic equation in form of frequency domain function. And solution for this frequency domain signal or function can be inverse Laplace transform again into time domain function. So it is easy to solve this algebraic equation in the form of the frequency domain. That's why this Laplace transform is important. Now, advantages of the Laplace transform. So solution of integral differential equation of the time system can be easily obtained by the Laplace transform. Initial conditions are automatically incorporated with the use of the Laplace transform. Now, Laplace transform provides an easy and effective solution of many problems arising in automatic control system because they are dependent on the time varying system. So Laplace transform allows the use of graphical techniques for predicting the system performance. Now definition for the Laplace transform. The Laplace transform of the function f of t is simply defined by capital F of s is equal to Laplace of f of t is equal to integration from 0 to infinity of f of t into e raised to minus st dt. So this is the equation for or definition for the Laplace transform, where f of s is the symbol of the Laplace transform and L is the Laplace transform operator, and f of t is some function of time. Note, the L operator transform a time domain function into f of t into s domain function f of s. S is a complex variable where s is equal to a plus bj or j into b into square root of the minus 1. We know that square root of minus 1 is nothing but the value of j or imaginary term I. Now standard Laplace equations f of t f of s. So for the unit step function, the Laplace transform is given by 1 of s. For e raised to minus alpha t, it is given by 1 by s plus alpha. For sin omega t, it is omega by s square plus omega square. For cos omega t, it is s divided by s square plus omega square. E raised to minus alpha t sin omega t omega divided by s plus alpha square plus omega square. E raised to minus alpha t cos omega t s plus alpha divided by s plus alpha square plus omega square. For the t, 1 upon s square t raised to n factorial divided by s raised to n plus 1. E raised to alpha t minus alpha t into t raised to n factorial by s plus alpha n plus 1 raised to n plus 1, and the function delta of t, the value of Laplace is 1. Now inverse Laplace transform. By the definition, the inverse Laplace transform operator L inverse converts an S domain function back into the corresponding time domain function. So f of t is given by inverse Laplace for the f of s. So Laplace transform of the passive elements R, L and C. The Laplace transform can be used to independently on the different circuit elements like R, L, C installed entirely in the S domain, which is much easier. Let's take a look at some circuit elements. So first, resistors. Laplace transform of R. Resistors are time and frequency invariant, therefore the transform of a resistor is the same as the resistance of the resistors. So Laplace of resistor is simply given by R of S. Now Laplace transform of the capacitance C. Let's look at the relationship between voltage, current and the capacitance in the time domain. So I of t is equal to C dVt by dt. Solving this equation, we will get the following integral. V of t is equal to 1 upon C 0 to infinity I of t dt. So simply take subject dvt, and this will become 1 upon c over here, and for this dt term we have to provide integral 0 to infinity. Then the transforming this equation into the Laplace domain, we get the following V of S is equal to 1 upon Cs, 1 upon S, I of S, because we know that the Laplace for this 1 upon Cs is given by Cs. So this is the Laplace for the capacitance. Now again, if we solve for the ratio Vs by Is, we will get the following: Vs by Is is equal to 1 upon Sc. So Laplace of capacitor is given by 1 upon Sc. So we have to multiply S with this capacitor and take its inverse for the Laplace of any capacitor value. Now Laplace transform of the L means Laplace transform of the inductor. Let us look at the relationship between the voltage, current and inductance in the time domain. So it is given by V of t is equal to L DEPT by dt. Putting this into the Laplace domain, we get the formula V of S is equal to S Li of S, and solving our ratio V of S is equal to divided by I of S is equal to SL. So therefore the transformation of the inductor with the inductance L is given by L Laplace of inductor is equal to S of L. So simply multiply the value of inductor with the S function. So let's take one example for the RC and RLC circuit element. So this is the example: find the transfer function of given RC network. So this is a RC network where R and C are connected in parallel. So this is input voltage VIT, this is output voltage V of t, and this is the circulating current I of t from this resistors and capacitance. So now apply KVL for the input loop. Apply KVL for the input loop. So it is given by V of IT is equal to RIT plus 1 upon C 0 to T I of t dt. So this is the KVL for this closed loop. Now taking Laplace transform for the above equation. So it is given by Vi of S is equal to Ri of S plus, we know the Laplace transform for the capacitance C. So 1 upon Sc I of S. So this is equation number 1. Apply KVL for output loop. So it is given by V of t. V of t is equal to I1 by C 0 to T I of t dt. So taking Laplace transform for the above equation, Vo of S is equal to 1 upon Sc I of S. So now I of S is given by Sc Vo S. So from this equation number 1, we can write Vi of S is equal to Is in bracket, take Is common, so Is into R plus 1 upon Sc, R plus 1 upon Sc. We have to take common this Is term. So now from the equation number 3 and 4, we can write Vi of S is equal to Vo of S into Sc divided into R plus 1 upon Sc. So simply put the value of Is from this equation number 3. Put the value of Is over here from the equation number. Now so transfer function is Gs is given by V of S divided by Vi of S. Laplace of output divided by Laplace of input is equal to nothing but 1 upon Sc into bracket R plus 1 upon Sc. So again solve this equation and take LCM for this term. So it will become Sc R plus 1 divided by Sc. So Sc will cancel out. So our transfer function will become V of S divided by Vi of S is equal to 1 upon SCR plus 1. So this is the our system in form of Laplace equation. So this is our input in form of Laplace, this is output in form of Laplace, and this is our transfer function for this whole circuit. So for this circuit, our transfer function is right like 1 upon SCR plus 1. Now same for the RLC network. So here RLC network is here, Vi of t is input, V of t is output. So same, consider KVL for this input loop. So it will write like this: Vi of s is equal to RIS plus SLIS plus 1 upon SC into IS. So VIS is given by taking this is as common, so R plus SL plus 1 upon SC into I of S. So this is equation number 1. Now apply KVL for the output loop. So it is V of S is equal to 1 upon SC into I of S. So this is equation number 2. Now from equation number 1 and 2 we can write transfer function V of S into Vi of S is equal to 1 upon SC into IS divided by R plus SL plus 1 upon SC into IS. So IS will get cancelled out. So our transfer function will 1 upon SC divided by R plus SL plus 1 upon SC. Now take LCM for this denominator term. So SCR plus S square LC plus 1 divided by SC. So this SC will cancel out. So our transfer function will become 1 divided by SCR plus S square LC plus 1. So this is the transfer function for this figure RLC network. So now important questions regarding this video lecture. What is control system? Explain difference between linear and non-linear system. Maybe ask for 4 marks. What is a control system? Explain difference between time varying and time invariant systems. What is the third question is Laplace transform. What is Laplace transform? State its advantages. 4. What is the transfer function? Explain in brief. So this is the important topic regarding examination. I hope you understood it.